Okay, so yeah, last time we took a look at this this question that we wanted to use to make a decision. Can I go to the movies? And we knew that we're allowed to go if it's before 8 o'clock. And so what we did is we thought about, well, what's the information we need to know? We need to know what time it is in order to answer that question. We decided that one really good variable name for this piece of information would just be time. And so if we look at this slide, what we're looking at is called a flowchart, which helps us kind of visualize the decision that we would make, but also how a computer looks at it as well. So based on whatever this time variable, whatever value it has, we can then use that to evaluate this conditional statement. So let's say that it's 9 o'clock. So what we would do then is we would assign the time variable the value of 9. And now what we can do is we can move down this flowchart, and where we see time, we can go ahead and bring that 9 down. Okay, so now what we're seeing is 9 less than 8. We know that 9 is actually bigger than 8, so we know that this statement, this expression is false. So from there, we're going to look at the two branches here, and we see one is true and one is false. Well, we decided that our statement was false, so what we're going to do is we're actually going to travel down that false branch in order to see what decision we're going to make. And that decision is, no, I can't go to the movies. Okay, so this is kind of how computers look at decision making. Let's go ahead and look at another example that we can then apply to looking at another flowchart. So this one is a little bit more complicated because there's going to be two pieces of information that we're going to need to know in order to answer this question. So the question is, have I won the game? And I know the answer to this question if my score times my lives is greater than 10. So what information do I need to know in order to answer the question, have I won the game? And what's a really good variable name for both of these pieces of information? What you're going to do is you're going to write the variable names on the plastic baggie, label them by name. Don't worry about writing anything on the sticky note because that's where the value is going to go. We're just concerned about what's a good variable name for the two pieces of information you need to know. So I'll give you a little bit to do that. So at this point, go ahead and switch to your Pear Deck slide and annotate on the slide. All right, so I see some people still working on it, but that's totally okay. I'm just going to show a couple of examples of some variable names that you came up with. So a few different people came up with this answer of just score and lives. That's that's the simplest case. And remember, you want to keep it simple, you want to keep it short, but at the same time, you also want to have meaningful names. Someone put score and my lives. That also works as well. But for this particular example, I think we're going to stick with just score and lives. I think that's what I used on the next slide. So as you can see, we've got our two variables here in memory, score and lives. And we're going to need to know what those values are in order to make that decision. So again, the decision we're going to make is, have I won the game? And then I know that I have won the game if my score times my lives is greater than 10. So if we look down here in the gray diamond, that second sentence is represented by this conditional statement. Score times lives is greater than 10. Now, what we're going to do is we're going to practice using the flowchart with these test values here. So I can go ahead as an example, do the first one, and then you're going to complete the second two. So this is how we would do it. I'm going to go ahead and annotate on my screen here. So test number 1 says score is 3. So I'm going to go ahead and write, oops, I don't want a line. I want an actual pen. There we go. So I'm going to write 3, the value of 3 inside of this variable score. And then lives is also going to be 3. So I'll go ahead and write that there. And then the next thing I want to do is I want to move down into my flowchart. And this is where I pause and I say, okay, well, this is the conditional, so I need to evaluate this. It says score times lives is greater than 10. So I want to bring down the value from score and put it right there. And then I'm also going to bring down the value from lives and put it right there. So now I have 3 times 3. So now I can go ahead and reduce that math to 9. And now I have the statement 9 is greater than 10. So I know that 9 is not greater than 10. So this is going to evaluate to false. So what I want to write on the right here on my blue sticky note is the Boolean value false. Okay, and then the decision is I have not won the game yet. So now what you're going to do is you're going to go to your own pair deck slide, and you're going to do the same thing with tests number 2 and 3. So I'll give you a moment to work on that. Please let me know if you have any questions in the chat or hop on the microphone. Hey, Flor. What if the number is negative? So is a negative number going to be bigger than a positive number? Oh, hey, Mason. That's okay. That's a good question, Flor. We'll go over it in just a sec. Okay, let's see. Let's take a look at an answer. Okay, so here is a student's work. They decided that all 3 are false. We already did test number 1 together, so let's go ahead and walk through test number 2, and then we'll take a look at that test number 3 where we have a negative value and talk about how we deal with that. So test number 2, we see that score is 1 and lives is 10. So if we bring down those 2 values, we get 1 times 10, and 10, is that greater than 10? No, they are the same value, so this is false. Okay, so this one is correct. Please let me know if you have any questions about that one. And let's do the third one, where we have that negative value. So in that one, we have a score of -5. Not doing too well. And then lives is 2. So let's bring down those values. So we got -5 times 2. So now what we wind up with is -10. And what we're saying is -10 greater than 10? A negative number is always going to be smaller than a positive number. So -10 is not bigger than 10. This is false. And the reason for that is, think about the number line where we have 0 in the middle here. Let's say we have like 10, I'll put 5, right? Everything to the right of 10, everything to the right of 10 is going to be bigger than it, and everything to the left is going to be smaller than it. And so over here on the left-hand side of the 0 is going to be our negative numbers. So -10 is smaller than 10, okay? All right, any questions on that? All right. Please feel free to interrupt me on the microphone or in the chat. I'm constantly monitoring the chat. Let's go ahead and move on to the next example. Okay, here's our challenge. So again, we have a question we want to answer, and we need 2 pieces of information. So the question is my dog older than me if his age is converted to human years? Okay, so if you don't know, basically they say that 7 dog years equals 1 human year. All right, so what information do I need to know in order to answer the question, is my dog older than me? What 2 pieces of information do I need to know? You can go ahead and write down what you would call the variables that stores those pieces of information on this paired X slide. All right, let's take a look at some examples. Let's see here. We've got dog age and human age. It's a great one. Short and to the point. Your age, age of dog. That's good too. And we got my age, dog age in human years. Kind of a longer one, but it still works. Dog age in human years, dog years, human years. Yeah, all these are great examples. I think I use dog age and human age on this next slide. So that's what we will see. So here we got dog age and my age, right? So we're pretending that I am the human. Okay, so let's think of an example here. Let's say that my dog is 3 years old, and let's see, most of you all are about 17, so let's go ahead and put 17. Now, I want you to kind of work through this process. I know I forgot to put an annotation on here, but will this Boolean evaluate to true or will it evaluate to false? Okay, let's see one true on here. So again, we're gonna bring down that 3. I see a bunch more trues. So bring down that 3, right? And 3 times 7 is 21. 21, is that greater than my age? 17? Yeah, 21 is bigger than 17. Right? 21 bigger than 17. It's okay, Diane. I'll make mistakes. So true. My dog is older than me. Okay. So I think I've got another example for you to work through here. Let's see. Let me erase this. Oh, I still have the eraser. There we go. All right. So what we're ultimately leading up to here is this idea of compound Booleans. If my decision requires, more than one true or false. So if my decision requires several steps. So this question is, can I adopt a cat? And this question depends on the answer to 2 different pieces of information. So I can adopt a cat if I have $40 and if I am over 14 years old. So let's take a look at, first we're going to take a look at a way that we can do this in 2 steps. I know I'm skipping this, but for the sake of time, let's just go ahead and say that we're going to use the variable name money for the amount of money that I have, and the variable name age for my age. Okay, so again, I can adopt a cat if I have $40 and if I am over 14 years old. So I'm going to have to evaluate 2 different Boolean expressions here. So the first thing in this flowchart is whether or not I am over 14 years old. So we're going to kind of go through the same process here. We're going to bring down the value inside of age. 17. Is that greater than 14? Yeah. We're going to branch over here to the true side. But then we have another decision to make. We're asking, is my money equal to $40? So I'm going to bring down money, 39. 39 is not equal to $40, and so this is going to be false. And so we're going to branch over here. Oops, there you go. I cannot adopt a cat. I'm guessing that you have to have exact change, right? Because it says exactly $40 here. Okay, but this is just one way to represent this decision-making process in 2 different steps. We're going to learn how we can put this we're going to learn how we can put this into just one step using compound Boolean expressions. Okay, so we'll come back to this example in just a bit. Oh, I keep forgetting that I actually have the slides for that. Okay, so in order to do compound Boolean expressions, we need logical operators. So we are going to be talking about 3 different logical operators in this class. Those 3 are called and, or, and not. So when you see pseudocode, like in a textbook or on the AP exam, since it doesn't use a particular programming language, you're going to see the words and, or, and not, usually in all uppercase like this. When we move on to programming in JavaScript, and if you've used Java as well, it uses the same symbols. You're going to use these. So double ampersand is and. These vertical lines are called a pipe. So this is double pipe is or. and then your exclamation mark is going to be not. Okay, so we're going to be looking at what's called truth tables for each of these logical operators. Okay, so let's go ahead and do that now. So the first thing we're going to look at is we're going to look at the truth table for AND. When we look at these truth tables, you're going to notice that we're still going to use blue stickies for our Boolean values, but we're going to use a dark blue for true and a light blue for false, just to kind of make it easier to differentiate. So let's look at AND. So when we're using the AND, we can put a Boolean value to the left and to the right of it, okay? So here is all the possible combinations using AND. You got true and false, false and true, and false and false. So let's take a look at what these each evaluate to. So true and true evaluates to true. True and false evaluates to false. False and true evaluates to false. False and false evaluates to false. So I want you to take a moment and take a look at this. Do you see a pattern? Take a look at what's on the left versus the left of the arrow and on the right of the arrow. And do you think you see a pattern? And if so, what is that pattern? Anything with false is false. Okay. So if you see at least one false, it's going to evaluate to false. Diane, what do you mean greater than true? Do you mean like it overrides, like the presence of one false overrides the truth value? Like if there's just one false, the whole thing is false. It negates the whole thing. That's a good way of looking at it. So this is true. This is, yes, for ands, if you have just one, even just one false, the whole thing becomes false. In order for an and statement to be true, both sides do have to be true, right? That's the big idea here. Both sides of a Boolean expression using an and has to be true in order for the whole thing to evaluate to true. If there's even just one false, the whole thing becomes false. Okay, so that's the big idea here. Next, we're going to look at or, which is going to be a little bit different here. So here's or. Or evaluates like this. So we've got true or true is going to be true. True or false, also going to be true. False or false or true is also going to be true. False or false is going to be false. What pattern do you see here? Pay attention to this side in relation to the rest. Oops, there we go. False has to, oh, hang on, let me go to the top here. Vice versa than what it was before. Okay, false has to be with another false to make it equal false. True is greater than false in terms of true and false. Contrary to and. Yeah, so in this case, if you have even just one true, like you have a true here, you have a true here, and in here we have both sides being true. If you have just one true, the whole thing is going to be true. And this is for or. The only way to get a false using an or is if both sides are false. Okay. So yeah, this is kind of the opposite of and, right? Where and, both sides have to be true for the whole thing to be true. But if you only have one false, the whole thing becomes false. Okay, so the big idea oops, the big idea here is that either side can be true for the whole thing to be true. So one side has to be true, or both sides have to be true for the whole thing to be true. And the only way that it can be false is if both sides are false. So in that one, it has to be one true for it. Yeah, just one true. It can be both or just one. Exactly, because it's like either or. Yeah. All right. The last one, the last compound expression, or sorry, operator is called not. And not is probably the easiest one because it just takes the opposite. So not true is just going to be the opposite of true, which is false. Not false is just going to be the opposite of false, which is true. That's all you have to know for that one. This table, much simpler than the other two. Okay, so you just take the opposite. So now let's revisit this question of, can I adopt a cat? Last time we looked at how we had to have two different layers of decisions. Now that we have this and operator, we can combine these two conditions together. So let's take a look at what that looks like in this flowchart. So same thing, we have the two pieces of information we need, money and age. But now notice that we've created this compound Boolean expression, and it's linked together with and. So let's see, what are the values here? So let's pretend that my money is $40 and my age is 15. All right, so let's bring down the 40. There we go, and the 15. So 40 for the money, 15 for the age. And now we can evaluate this statement. Remember, for an and to be true, both sides, so this is the left side, and this is the right side, both of these sides have to be true for the entire thing to be true. If any of the one sides is false, then the whole thing becomes false. So let's see what happens. Is 40 equal to 40? Yeah, 40 is equal to 40. And then is 15 greater than 14? Yeah, 15 is bigger than 15. So in this case, both sides are true. So that means that the whole thing is what? It is true, yeah. So we're gonna go ahead and branch to that true side. And guess what? I can indeed adopt a cat. Yay, cat. Awesome. Okay, so now we saw how we could kind of simplify things using these operators. That's going to come in really handy. Um, so since we don't really have time, we're going to skip this part and we're going to move on to just the key takeaways. In bold, you'll see the key vocabulary that we have covered. So a Boolean value is a data type that can be true or false. Here are all the comparison operators that we covered. And then just some key ideas that each side of a Boolean is reduced to a single value. Single values are compared and result in a Boolean value, true or false. And I'll be posting the video of this, so if you didn't get all that information, don't worry, you can go back and get it. And then last, Boolean expressions can also include these logical operators, and, or, and not. Both sides have to be reduced to a single Boolean value in order to evaluate the compound expression. Truth values, make sure you really understand the truth tables for each of these operators. Again, I'll be posting this video after class, so you can go back and see those. And a decision is made with a single Boolean value of true or false. And then we looked at flowcharts today. So flowcharts illustrate the steps of making a decision with a Boolean expression. And that's it. I'll post this video so you can watch it at your leisure about George Boole, whom Boolean values is named after. He was a logician. And yeah, that's it. Thank you so much. And remember that tomorrow, Friday, is a 135 day, so I will not see you. But I hope you have a very restful weekend, and I will see you all on Tuesday. Have a great day. Have a great weekend. Bye, everyone.